Okay, a z-score. You want to write this on your cheat sheet. I will give you the formula, but when you look at the formula, do you know what everything means? So maybe write this on your cheat sheet. Z-score equals your score minus the mean over the standard deviation. So that's the formula. So write down that formula on your formula sheet with words. Because I will give you the formula, but when I give it, it's in all these weird letters. So if you write it on your cheat sheet in words, it'll be more helpful. Standard. What does it stand for?
Scooby-Doo. Write that on your cheat sheet.
Okay.
Pi symbol?
It's kind of weird, but this symbol and this symbol, no, mean. Sorry, just kidding. This symbol and this symbol can both be used for mean. One is used when you're talking about a sample, and one is used when you're talking about an entirety. That's the difference. But no, that's why I said let's just write it on your paper with a word, the mean. So now we don't have to think about it. What are all these symbols? Okay, so we learned about this curve yesterday, and we learned the mean, right? That's the mean, always in the middle. We learned that we could go 1, 2, 3 standard deviations up, 3 standard deviations below. When I use these 1, 2, 3 numbers, those are called z-scores. So if you are exactly a z-score of 2, what does it mean? You are 2 standard deviations higher than the average. That's what it means, okay? If you have a z-score, so on a math test, if I tell you your z-score is -3, that's probably not a good thing, because that means you're 3 standard deviations below the test average. Okay, so let's see. We have 155. Okay, I can tell it's exactly 1, but let's go with the formula. So Z equals my score. So if I scored 155 minus the mean, so I'm going with that formula, my score minus the mean, so minus 150 over, and it told me the standard deviation was 5. When I type this into my calculator, I would either have to hit enter or brackets before I divide. So I would type this into my calculator, brackets 155 subtract 150, and then divide by 5. And we're right, it's 1. Okay, I can see 140 exactly would be a -2, so let's practice using the formula. How did you get that? So Z equals my score of 140 minus the mean, so minus 150, over the standard deviation of 5. Again, in my calculator, I would put that in brackets, and I'm going to have some self-awareness here that if anybody's ever scoring under the mean, they better have a negative z-score, right? Does that make sense? If you're under the mean, you should have a negative z-score. Okay. Now, more than often not, we use this because our z-scores aren't perfectly lined up. Okay, so a score of 158. So if I visualize it, 150 was there, right? And then what did we do? 155, 160. Okay, that was my thing. I'm trying to figure out where does 158 fall. So now, do you see that it's like here-ish? Right? That's where 158 is. Now, I for sure know the z-score is somewhere between what and what? Somewhere between a score of 1 and 2. Right? I know that from where it's located. Okay, so let's figure it out. The z equals my score of 158 minus the mean over the standard. Okay, and this one will be a decimal because it's not exactly on. And I got a number of 1.6, a z value. I'm 1.6 standards above the average. Okay, and we were right. I predicted it was between 1 and 2. Okay, so 141. So there was the 150. You don't have to draw this. I'm just drawing it to make sure you understand what I'm doing. So there was a 145 and a 140 and then a 135. So I am looking at 141. So I would be right here. Okay, I'm going to take a guess. Anybody want to take a guess? What would the z-score probably be? Because this would be -1 and this would be -2. Okay, so I'm going to guess -1.7, -1.8. I don't know. Okay, so z equals my score, subtract the mean over the standard. And how was our prediction when you're done? I got -1.8. Does that make sense? Where it is? Okay, now we're going to work the opposite. What would be our score if we had a z of 0.8? So if 150 is there, the next one up is 155, right? That's a z of 1. So I'm going to be like that. I'm going to be like there, right? I'm going to be 0.8. So my guess is like 153, 154. Okay, so let's figure out the exact. So when I do this formula, now I'm going to go 0.8 equals, because now I was given the z-score. My score, which is the thing I don't know now, so I'm switching my variables, minus the mean over the standard. Okay, so I took the formula. Last time we knew my score and wanted to figure out z. This time I know z and want to figure out my score. I need 2 algebra steps. What are they? First, I'm going to times by 5, right? Does that make sense algebraically? And then I'm going to add 150. Okay, and the score that I got there, 154, that makes sense because it's right here, a z-score of 0.8, because 155 had a z-score of 1.
Okay, what did we do with the 0.5 again?
where do you see a 0.5?
Underneath the.
Times by 5.
Oh, times the.
Sorry, I just didn't want to put an X because there's I'm timesing by 5 is what I did. Should I just do like brackets like that? Times by 5. Times by 5. Is that better? Okay, same thing. I'm just going to give you a visual. You don't have to do this. But there's 150, negative 2.9. I'd be way down there, right? I'd almost be at the bottom. Okay, so what score would be way down there? So negative 2.9 equals some score minus the mean over the standard. Okay, same steps. You'll have to times by 5 and add the 150. Oops. And I got a 135.5 as the score that I would be at. Okay? So this is what Z scores mean. Okay. Can you go to this page? I'm going to do a couple on here. So now, where am I at? So page 13 is where I'm at. Okay. Number 1. So now we're going to take our Z scores and figure out what percent is between them. So do you remember yesterday we did that crazy looking chart? I think I lost mine already. Do you remember that bell curve? And then we were like, between the 1 and 1, there was 68%. You remember like that kind of stuff? Okay. Now, this is what we're going to do when the Z scores aren't the perfect 1, 2, 3. Okay? If I have a Z score of 1.8, I can't do that method that we learned yesterday. Okay, so here's the first question. What percent of the data is below negative 1.96? Okay, so where is negative 1.96? It's about there, right? It's kind of near the bottom of the curve. And I want to know what percent of the data is less than that. Okay, cheat sheet time. We're going to put some stuff in our calculator. Okay, you ready? The button is called VARS. You're going to do option 2, which is called normal CDF. Are you in that menu? VARS number 2 is called normal CDF.
Where?
I hit the button called VARS.
Okay.
You see a VARS?
Bars.
Oh, sorry. You have to hit second VARS. Just kidding. I'm sorry. That's my fault. You have to hit second VARS because it's a distribution. Sorry. Now it's there?
Yeah.
Sorry. So distribution, which is second VARS. Okay. Normal CDF. Enter it on your screen. Okay. And it gives you a bracket.
Which normal CDF? There's 2.
The first one is a PDF.
Oh, okay.
So you want the CDF. And I think I remembered my class thinking about it like this, cats and dogs. Because they always forgot which one it was. Is it the PDF or CDF? So cats and dogs. Okay. Now, here's what you put in the brackets.
Bless you.
Bless you. You're going to go like this. The lowest to the highest, mean, standard deviation. Yeah, you're going to have to type in 4 things, and you're going to separate them with commas. Okay, so if I look here, my lowest is below this. On a graph, we've been graphing our quadratics. What happens on a graph if you just go below? Where do you go to? Negative infinity, right? Right? This technically does keep going, 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 going. Okay, so negative infinity. Unfortunately, your calculator does not have an infinite symbol. So here's what I'm going to do for negative infinity. Negative 99999. I don't know. About 5 or 6 of them should do. So we went from negative infinity. This is like a domain. Yep. And then we're going to go up to negative 1.96. So comma, negative 1.96, comma. What is the mean when you look at just z-scores? What number is in the middle? What's the z-score in the middle? 0. And what do z-scores go up by? Because we go from 0 and then we have 1, 2, 3, so we're going a standard of 1. Okay, that should answer our question. So my calculator is giving me that. It gave you quit. Why did it give you quit? Did you push a subtraction symbol or a baby negative symbol? Anybody else? Good? Yeah, baby negatives. Okay, now I'm going to answer that by moving this 2 decimal places. So I'm going to say 2.5% of the data is going to be in this zone below.
Why don't we have that data? That table.
Why don't you have that table?
Yeah, because it's just this.
Yeah, because you never learned this. This would be by doing it by hand, and you have a calculator. So if you really want to learn by the table,
Where do we put that answer on?
so you're right here. So did you not just do it right here?
Oh, okay.
So did you go negative 99999, comma negative?
Wait, we were supposed to do 5 nines. I thought it was 6 nines.
It doesn't matter. Not going to make a difference. You could do 100 nines in there. I don't care. Just a bunch. Just say a bunch.
Okay.
Just click it till you get, okay, 9999999. Okay, move on. I don't know how many I did. Okay. Next question is, what percent of the data is above the z-score of 1.15? So 1.15 would be kind of over there, right? It's above my center line, because my center line is at 0. So I'm at 1.15, and then it says above. I want to know how much of my data falls in that zone. Okay, so we're going to get to our feature. Let's just write it down first. So this would be that. We're going to get to the buttons. So what is the left? What's the lowest I'm at? 1.15. So this is a domain, right? from there, and then we go right. And we keep going right. So now I'm going to hit 99999, whatever, however many you do, comma the mean, so what number's in the middle, 0, and then the standard deviation, my z-scores are jumping by 1. So again, second vars, number 2, I got 12.5%. You have to do commas between all 4 of those things. Make sure you have a separate comma on each part. So you need 3 commas in there essentially, right? Like my calculator was giving me 0.125, and then I move it to say 12.5%. Okay, I'm going to do one more example, and it's not on here. I have to make something up because we didn't do one like this. How about I say between -2.1 and 1.8. Let's do one like that. So what percent of the data is between -2.1 and 1.8? Okay, that's my question. Okay, so you're going to hit the feature, you're going to go the normal CDF, and then you're going to do what's the left to the right, so -2.1 to 1.8, and then comma, the mean in the middle is 0, and this is on a scale of 1. And I got 94.6% of the data. Is that what you're getting?